Good morning, prodigious Panthers. Long time no see. Miss Sosa here, and we're going to go ahead and work on our math lesson for today. So if you would please get your copy of your math book and turn to page 496. We're going to go ahead and continue our work on polygons. The lesson that we're going to work on today is on triangles, okay? I'll give you a moment to turn your page to open to the page. Alright, so I'm not going to spend too much time on the vocabulary because I know that you've covered this with Ms. Frausto. But some of you do not have her, so I just want to go over the terms one time before we go into the lesson with finding the missing angles, which is what I want to focus on today. Alright, so let's start with the word triangles. Tri is the Latin root for the number 3. So when we're talking about triangles, we're talking about 3 angles. And if you remember back to our lesson on polygons from last week, if a 4-sided shape has 4 sides, 5-sided shape has 5 sides, how many sides does a 3-sided shape have? Three angles. Did I say that right? 3-sided shape has 3 angles. Yes, correct. So, triangles are named by 2 classifications. The first can be by sides, or the laterals, and the second is by their measurements of their angles. So let's just review the terms and see if you remember them, okay? The first one we're going to cover is equilateral. Equilateral. If you see the word equi, that's Latin for what? Equal, correct. So equilateral means that all 3 sides are equal length, which is what I drew here with my little carrot sticks, if you will. The second one we have are the isosceles triangles. Now, isosceles is where you have 2 equal sides. And then the last one you have is scalene. And you have 0 equal sides. They're all different measurements. Then you have the angles. So let's go over those. Angles, we have a right triangle because it has 1 right angle. Now, an acute triangle has to have 3 acute angles. None of them can be right, none of them can be obtuse. 3 acute angles. And then finally, the obtuse triangle, which means it has 1 obtuse angle. Okay? So, if you remember this, you're going to be just fine. So, on the warm-up, they have us drawing with a protractor, which unfortunately I know most of you didn't bring with you. So we're going to go ahead and move down to the bottom half of page 496. How can you find an angle's measure in a triangle? So let me go ahead and draw that up for you guys, and then let's figure it out together. Now, does anyone know how many degrees are inside of a triangle? If you said 180, really good. If you didn't, well, now you know. So, let's make sure we make that note. The angles, actually, let's correct that. The sum of all the angles in a triangle is equal to 180 degrees. So, if you know this information, it can help you figure out a lot of different triangles missing angles. So let's look at what we know about the triangle on the bottom, an example, okay? So you have this drawing here, and you have triangle K, J, and L, and this is 70 degrees, and this is 25 degrees. We don't know what K is, so we're just going to write a question mark. Well, what did I just tell you about the measures of the angles inside of a triangle? They all equal 180 degrees, correct? So let's write an equation. So if I were to write this equation, what would I have to do to all the angles? You have to add them up first. So let's go ahead and write it up. So you have 70 degrees plus 25 degrees. Now, do I know for K? No, I don't. So I'm going to put a variable. Guess which variable I'll put? I'm going to put K. So plus K equals 180 degrees. With me so far? Yeah, you guys are with me. So, what's the first step to solving for K? What do we have to do first? We have to add, of course. So we're going to add the 70 and the 25, and that should give us 95 degrees. Plus K equals 180 degrees. All right. Now, we're almost done. If I want to get K by itself, what is the inverse operation of addition? Subtraction, right. So what are we going to subtract to get K by itself? The 95, because we want to get rid of the 95. But remember, this is an equation. So if I need to keep it equal, I have to do what? If you said, if what you do to one side, you do to the other. Thank you. You've been listening. So let's subtract 95 on both sides of the equal sign to keep the balance. So 95 minus 95, again, it's canceled. And that leaves me with K. Now we do 0 minus 5, can't do that, so I borrow from 8, which becomes 7. 10 minus 5 is 5. 7 minus 9, can't do that, borrow. 17 minus 9, that gives me 8. So K equals 85 degrees. And you just found the missing angle. Now this, I know, is something new for you guys. This is pretty easy, so this should be exciting for you. So let's go ahead and continue on to page 497. Now, I'm going to focus on numbers 1 through 4. Let's do those together first, and then after that, we'll look at number 5. Well, we'll look at it. We can't really, unless you took your rulers home, then you can draw this. But if you didn't, we're going to eyeball it, okay? All right, so let's erase that. All right, so we're on to page 497. We're on the check. Okay, so we have the first triangle. You have 68 degrees, 54 degrees, and then we don't know, X. I'm not going to write the sides because that's, they do want to classify it too. So we do have to do all this wonderful work. So 40 inches, 46 inches, and finally 42 inches. So let's go ahead and solve for the X variable, and then we'll figure out the classifications, okay? So we'll go ahead and remember, the sum of all the angles equal 180. What's the equation we're going to do? Right, we're going to write the equation of adding all the angles and then equals 180. We'll figure it out from there. So we have 68 degrees plus 54 degrees. Do I know X? No, so we're going to write X for now. That's my variable. And it equals 180 degrees. So we got 68 plus 54. What do we get? 8 plus 4? That gives me 12. Carry the 1. 1 plus 5 is 6. 1 plus 5 is 6. 6 plus 6 is 12. I have 122 degrees plus X equals 180 degrees. So what do we do now to get X by itself? What is the inverse of addition? Subtraction. So we're going to subtract 122 on this side, and what you do to one side of the equal sign, you do it to the other. Okay, you cancel out 122. That leaves me with X. I can't do 0 minus 2, so I borrow from 7. 10 minus 2 is 8. 7 minus 2 is 5. So x equals 58 degrees. Now, we solved for x. Whoops, 1 second. My computer just turned off for a second there. All right, so we already found for x, so let's classify. Let's start by angles since we have all the angles up here. So you have 68, 58, and 54. What do you notice about these angles? Are there any right angles, all acute, or an obtuse? They're all acute. So this is an acute triangle. But what kind of acute triangle? We have 40, 46, and 42. None of the sides are equal. So it's an acute, what? Acute scalene triangle. And Miss Sosa doesn't feel like running triangle. That is actually the symbol for triangle. Go ahead and copy that for yourself or your notes so you can be able to do the rest of the assignments later. All right, ready for the next question? I know you are. Okay. Let's start with number 2 now. So we have this lovely triangle. And this is x. This is 39. We have 14 centimeters. 17 centimeters. And 22 centimeters. I think we know the sides one, but let's go ahead. And we know the angle one, don't we? So before we go ahead and solve it, we already know. This is a right triangle, isn't it? Yeah, because it has a right angle. Any of the sides equal? So this is a right scalene triangle. But that is not the only thing you're supposed to do according to the directions. We also have to solve for the missing angle. So let's go ahead and solve it now. Again, I'm just going to write an equation where I'm adding all my angles. The right angle is 90 degrees plus 39 degrees plus, is it x every time? Yes, it is. X degrees equals 180 degrees. Now we add our 2 that we do know. That gives me 0 plus 9 is 9. 9 plus 3 is 12, 129, plus x equals 180 degrees. Now, again, how do I solve for x? What is the inverse of addition? Subtraction. 129, we're going to subtract it on both. And what you do to one side, you do to the other. 129 gets canceled out. That leaves me with x degrees. 0 minus 9 can't do, so 8 becomes 7. 10 minus 9 is 1. 7 minus 2 is 5. 51 degrees. X equals 51 degrees. And that's all the work you need for number 2. Okay, ready for the next one? All right, and if you aren't, you can always pause the video. Let's go on to number 3. Number 3 says, ooh, it's a tiny little thing there. And it's personally, I think, one of Miss Sosa's favorites. I think. Nah, it's not. .48 degrees and then x. Alright. Now, this time, they didn't give us any measurements. But you do know something. You know this side is equal to this side. So if 2 sides are equal, what kind of triangle is it? It's isosceles. Now let's figure out all the angles to make sure if it's acute, right, or obtuse. I can tell you right now it's not right. And it most likely is acute by looking at it. But let's just do the math to make sure, okay? So again, 66 degrees plus 48 degrees plus x degrees equals 180 degrees. So we add up our variable, the angles we know. 8 plus 6, what does that give us? 14. Carry the 1. Then we have 6 plus 4, which is 10, plus 1 is 11. So we have 114 degrees plus x equals 180 degrees. All right, what's the inverse again? Subtract. So we're going to subtract 114 degrees, and what you do to one side of the equation, you do to the other. 114 gets canceled out, leaving me with x degrees equals, can't do 0 minus 4, so we get 7. 10 minus 4 gives me 6. 7 minus 1 is 6. And 1 minus 1 is 0. 66 degrees. Wait a second. 2 equals 5 and 266. So what does that mean about isosceles triangles? If two sides are equal, two angles are going to be equal. Just like that, just like we talked about with polygons. There is some logic to it. You just got to learn the patterns. Alright, so again, were we right? Was this acute? Yeah, we were. So we're going to write it's an acute isosceles triangle. Ooh, that is a bad triangle symbol. Okay, I'll give you a moment to look it over. Okay, ready for number 3? Oh wait, no, this was 3. Number 4, I should say. Alright, let's continue. So number 4, we have, a very interestingly drawn one. I don't even think that's the best drawing of it, but hey, it fits the bill. This is 145 degrees. This is 5.8 meters. This is 23 degrees. We don't know for x. 16 and 16 meters. I'm not going to bother with the decimal point. Doesn't really change it much. 10 and 9/10 meters. Okay. So, you can run ahead without me. If you want to try to see if you can beat me, go ahead. But I'm going to go ahead and solve for x right now. So, I know I have 145 degrees, 23 degrees, and x degrees equals 180 degrees. I add up the angles I know. We got 8, we got 6, and a 1. And then we have x degrees equals 180 degrees. So we subtract because it's the inverse of addition. And what you do to one side, you do to the other. Gets canceled out, leaving me with x degrees. 0 minus 8 can't do. So 10 minus 8 is 2. 2 and 7 minus 6 is 1. That gives me 12 degrees for x. So, we solved for x. Now, what kind of triangle is this? Definitely obtuse, thanks to this guy. And how about the sides? Also scaling. None of the sides are equal. So this is an obtuse scaling triangle. Alright. You got that? Okay, good. So let's look at number 5. So number 5, they want us to draw a triangle with a 3-inch side between 40 degrees. Oof. We're going to skip number 5, guys. But I am interested in number 6. See if you guys can figure out for x. So, I'll give you a minute to think about it. Remember what I told you about isosceles triangles? What did I just say about the angles? If two sides are equal, what about the angles? Two sides are going to be also what? Two angles are going to be also equal. So let's solve for 6. I'm going to skip 5 because most of us don't have our rulers and protractors. And that is going to be tricky to do without those two equipments. Maybe with a ruler you can get away with it, but not without a protractor. So, I'm going to draw that lovely triangle here. This is right. I want to solve for x. So, oops, there goes my computer again. Alright, so, if I want to solve for x, what do I know? I know one angle is definitely 90 degrees. And two angles are equal. So what could we write it as? We could write it as x plus x, because we don't know what it is, and they're equal. Let's go ahead and do that. Now, we can't deal with two variables in one sentence, so let's go ahead and add it. What does it become? It becomes 2x. And if you said 2x earlier, yeah, you could have skipped this step, but I just did it for those who might have had trouble seeing it to begin with. So we have 90 plus 2x equals 180 degrees. So, again, we do the inverse. Let's get rid of the 90 by subtraction. 90 minus 90 is 0. That leaves me with 2x equals 9. Now 180 minus 90 is 90 degrees. Now, you have a 2x. What did I tell you when a number and a variable are together represent? It means multiply. Right. So what is the inverse operation of multiplication? Division. Correct. So we're going to go ahead and divide it. We're going to divide by 2 to get rid of the 2. 2 gets canceled out. X. And 90 divided by 2 equals 45 degrees. Very good. And that's all there is to it. Now they wanted us to find the value, and let's go ahead and classify it. What type of triangle is it with this right angle? It's a right triangle. Now, if you have two equal sides, what kind of triangle? It's isosceles. So it's a right isosceles triangle. So, that is today's lesson. That's what you're going to work on the activity sheet on the next page on 498. If you have any questions, please refer to the video. Text me on the Google Classroom, I should say. And I will be more than happy to get back to you before that happens. Before we go, I want to say I miss you all. And I hope you're all doing well and keeping safe, okay? Until next time, I'll see you later, all right? Oh, I have a guest here. Would you like to meet him? I'm going to introduce you to my dog, Monday. Come here, Monday. He wanted to jump in on the class. Ugh. Say hi, Monday. He's holding out. He's hoping you guys get to see me soon again, too. All right. Have a good night, guys. Bye-bye.